The ball is accelerated straight down by gravity along a line parallel to this vertical reference.
The cart is pulled along by a string which is wound around this phonograph turntable, and that pulls it with a constant velocity. When the cart passes this line, the ball is released, as you can see. The ball was released at that point. If it had fallen straight down, because the cart moves on in the time that it takes to fall, it would have landed back here somewhere, but it didn't. I'm going to fix this slow motion camera so that it moves with the cart. Like this.
Describe what you see. How does the ball move with respect to the person on the mast of the ship, with respect to a camera fixed on land? How does the motion of the ball knocked from the holder compare to the motion of the ball dropped from the mast? How does grabbing the ball make this sequence different from the previous one? Describe this motion with respect to the boat.
A ball rolling off the trough triggers a switch that drops a ball suspended from an electromagnet. Watch the motion of the two balls again in slow motion. What do you see? Note the positions of the two balls with respect to the point of launch, with respect to each other, with respect to the floor. Now horizontal and vertical lines are drawn to show the positions of the two balls at equal time intervals. What do you notice about the distances between the vertical lines? Between the horizontal lines?
Here's a model of a ball shot horizontally. The model shows the position of the ball at equal intervals of time.
What component of the projectile motion are you looking at now?
Here you see the horizontal component of a projectile's motion.
This curved motion can be analyzed into these two independent components.
A crossbow, made from the leaf of an automobile spring, is used to project a ball in the horizontal direction. A switch on the barrel causes the electromagnet to drop the target ball at the instant the projectile leaves the barrel. Where should we aim the projectile to hit the target ball? How do the vertical locations of the two balls compare? Step through this sequence and watch carefully. Is the flare always under the airplane?
Air resistance reduces its speed and the flare does not stay directly below the airplane. As seen from the Earth, it is horizontally projected. As seen from the airplane, it is falling freely from rest. This view shows the vertical component of projectile motion. If there were no air resistance, the motion would be constant acceleration. In this view, the effect of the air resistance is quite noticeable.
The horizontal components of the velocities of the flare and the snowmobile are zero. The velocity of the snowmobile is uniform both before and after the flare is launched. The flare travels along with it. The snowmobile slows down and stops after the flare is launched. The horizontal velocity that the flare had at launch is greater than that of the snowmobile. The snowmobile speeds up after the flare is launched. The flare lands behind it. A 15-degree launch. A 30-degree launch. A 45-degree launch. A 60-degree launch is shorter. A 75-degree launch is shorter still. The athlete is attempting to apply an equal force to the shot put each time. The throw, which is made at approximately 45 degrees, results in the maximum range. The target ball is suspended from an electromagnet high above the floor. The projectile is aimed at the initial position of the target. The balls hit each other. If the speed of the projectile is increased, the hit occurs at a higher location.